Hi, I'm Sevalad. Today I'll be sharing our project that is based on IPFS called Debox. Essentially, as the name suggests, we're adding another decentralized Dropbox to the ecosystem with our own spin on it. So we'll look at how Debox is working towards enabling greater decentralized storage acceptance among Web2 users, and also how Debox specifically uses IPFS to do that. So to start, a few words on the state of decentralized storage today, comparing the traditional cloud storage market with its decentralized counterpart. I came up with various estimates, but they all more or less fall into a juxtaposition of zettabytes versus exabytes. So a difference of 2 to 3 orders of magnitude. Now, even though the decentralized storage is an emerging market, I want to highlight a few more points that account for this size disparity. As we all know, decentralized storage is fairly non-trivial. So right off the bat, the complexity scares away many potential users. Have you ever tried to explain IPFS or Filecoin to a friend? Right? We've all done that. Decentralized storage also requires a certain minimum amount of IT knowledge, which most average internet users typically don't have. And finally, much of Web2 is built around certain workflows that underpin the functioning of modern society. And as a result, the Web2 usage paradigm, including the interfaces, applications, programs, has been really ingrained in user habits. And it seems that in many cases, trying to offer an alternative, Web3 applications, including decentralized storage, don't completely align with these common usage patterns. So let's talk about the good things about cloud storage. What are some features of cloud storage that make it universally accessible to most users? Native integration with the user's operating system. So essentially, all cloud storage solutions just work out of the box. In addition to a simple, easy-to-use web interface, many provide a desktop sync client that is integrated with the user's file explorer, enabling users to sync their data via local file system folder. Easy data sharing. Cloud storage not only enables you to easily manage your own files, but also manage the files that you would like to share with others, and those files that have been shared with you. And this is usually done through simple access control. Usually all users have an account with the cloud storage provider. A user can add other users to the access control list associated with a particular folder or file. And due to the centralized nature of cloud storage, a user can easily share data with another user that will be online after the first user has gone offline. And finally, fast and convenient data saving and retrieval. Cloud providers rely on high bandwidth infrastructure that enables supporting a vast user base. Generally, most users have a good and fast experience saving and retrieving data. And also, generally speaking, data retrieval happens at no additional cost to the average user. So let's talk about Debox. As mentioned already, in order to enable a greater acceptance of decentralized storage among Web2 users, to participate in bridging that gap, in other words, Debox aims to bring the good things about cloud storage that we just saw to the decentralized storage space. When designing Debox, we wanted to leverage existing IPFS core features while also adding functionality on top to achieve the following. First and foremost, Debox is designed with maximum user privacy as a primary feature. We don't use any auxiliary centralized infrastructure. Debox is completely based on the infrastructure of IPFS. We don't have any user registration or accounts to avoid tracking user usage. We offer no centralized API services, such as IPFS pinning. And finally, Debox is functionally independent from us, since we wanted to design a truly decentralized system. So going back to the good things about cloud storage, we'll look at these features and see how Debox is in the process of implementing them. Starting with a deeper look at the native integration with the user's operating system. So folders, they're everywhere. The folder usage paradigm lies at the core of the native integration of cloud storage with the user's operating system. Users primarily work with folders. When computers first appeared, we had local folders. When networks started to appear, we had the advent of network folders. And the next step in this evolution were cloud storage folders. They acted as regular folders, but were directly synced with cloud storage providers. So as we see, folders aren't going anywhere, at least not anytime soon. Within the folder usage paradigm, all operating systems have built-in features that all users employ, such as search, access control, access to individual file or folder properties and metadata, as well as additional functionality via context menu. And another thing to note, applications generally primarily interface with the local file system, so essentially building on top of this folder usage paradigm. So even though we have web interfaces and SaaS platforms, the folder usage paradigm still lies at the core of computer usage today. So who remembers WebDAV? Supposedly it was a thing a while back. For those that don't know what WebDAV is a protocol that enables users to perform standard file operations such as creating, deleting, moving, and copying files and directories on a web server. So what does this have to do with folders and integration with the user's OS? Well, a while back, we were looking at the prospect of using the folder usage paradigm to interface with IPFS. After some research and trying out various approaches, we quickly realized that we could achieve this using WebDAV. Since if we ran WebDAV as a local server, we could create an interface between IPFS and the operating system by obtaining direct access to IPFS's mutable file system, the MFS, as a mounted network drive. So this greatly improves accessibility to the data in IPFS. You can now directly interact with the files as if they were part of your local file system via your file explorer. Serving the files in such a way enables you to add any sort of arbitrary stream, file stream processing functionality such as file encryption and subsequent decryption. So you can have an encrypted file in the IPFS MFS. The same file, but decrypted, is then accessible via the file explorer. Any file manipulations would then be re-encrypted and reflected back in the IPFS MFS. Also, the fact that WebDAV is supported by all operating systems made this approach look promising. Again, native integration with the user operating system across the board, Windows, Mac, Linux, etc. So about a year ago, we created IPFS WebDAV. It's a module that does exactly the aforementioned. For those that are interested, it is available on our GitHub. The IPFS WebDAV proof of concept served as the initial inspiration for Debox. For those familiar with WebDAV, our implementation passes the official WebDAV server protocol compliance test suite called Litmus with 100% test coverage, demonstrating full compatibility when interfacing with IPFS. So at the core of Debox, we have the Debox FS. The Debox FS is similar to IPFS's MFS. In fact, we originally used IPFS's MFS but lacked certain metadata functionality, so we built our own Debox FS. It enables the user to work with the hierarchical tree structure of the files that are in Debox, and like with MFS, the actual files are stored in IPFS. So why not just use MFS? Well, we needed additional metadata support for implementing Debox-specific features, but we also wanted more data privacy than MFS provides. Using MFS, you can still see the size of files in IPFS, as well as the hierarchical tree structure of those files. We wanted to obscure this information to further enhance user privacy. So finally, as a step towards native integration with the user's OS, Debox uses WebDAV to enable access to the Debox.fs as a mounted drive, essentially bringing the convenience of the folder usage paradigm when working with files that are stored in IPFS. Well, not stored, but accessible. So currently in Debox, Debox.fs can already be accessed as a mountain drive, as I just mentioned, in the user's file explorer. We are also currently working on integrating Debox functionality into the file explorer context menu, which will look something like that. This would enable users, for example, to add files to Debox directly from their file explorer, to share files with others via Debox, to view Debox metadata for individual files. And we're also working on a desktop application, which would give the user easy access to all of Debox's additional functionality, such as searching, access control, file metadata, and sync state. So the next good thing about cloud storage that we'll look at, and that Debox implements, easy data sharing. To understand how Debox implements this feature, we'll look at how data sharing fundamentally works in Debox. Data sharing here refers to sharing data between individual Debox nodes, whether between users or between devices belonging to a single user. So let's go through a simple example. We have 3 nodes. User 1 wants to share a local folder with users 2 and 3. User 1 first needs to add the folder to his Debox.fs. And remember that a folder file that is added to Debox.fs is automatically added to IPFS, since Debox.fs is an abstraction. Next, to share a folder file that has been added to the Debox.fs, we use an abstraction, a Debox share, to internally denote that the folder file can be shared over the Debox network. Each Debox share has a state that defines the owner, share members, access level of members, such as read-write privileges, and the content IDs of the shared contents, and other metadata. Since the data itself is in IPFS, user 1 needs to somehow provide the content IDs of the share contents to users 2 and 3. Users 2 and 3 would then be able to retrieve the folder contents from IPFS using the provided content IDs. So how does user 1 provide the content IDs to users 2 and 3? Well, user 1 has a running process that users 2 and 3 can connect to and obtain the content IDs of the files in the share. We call this running process the Debox keeper. The Debox keeper manages the share state and enables exchange of metadata among share members, controls access to the share. User 1 provides access to users 2 and 3 by adding them to the share as members. And each keeper has an identifier, which Debox stores in IPNS. This identifier is used by share members to connect to the keeper in order to retrieve the share metadata, granted that they have the appropriate access. So using the retrieved share metadata, which includes the content IDs users 2 and 3, can then retrieve the corresponding share contents via IPFS. So while all these aforementioned abstractions provide access control for folder file sharing, IPFS does the actual heavy lifting and content routing under the hood. However, as you all probably know, IPFS does not provide any out-of-the-box encryption. So if anyone has the content ID of your file, they will be able to retrieve it and view its contents. And we needed a way to ensure that only share members would be able to share, to view the share contents. So we have to encrypt the data before it is added to IPFS and distribute the decryption keys to the intended recipients, the share members. And after evaluating various potential solutions for this problem, we realized that certain key abstractions used in Signals protocol mirrored those in the data sharing flow used in Debox. So we decided to use it. The Debox Keeper provides similar functionality to Signal Server. Debox Client corresponds to a Signal Client app. Debox Share is similar to a Signal Group. Debox Share Member corresponds to a Signal Group member. And finally, an event in Debox referring to changes in the share state, in the Debox share state. It behaves like a Signal message. And, Signal is also trusted by big names such as WhatsApp, Facebook, Messenger, Skype, proven to be reliable by extensive third-party auditing, and the code is well-maintained and accessible for developers. So using our Debox protocol, which is based on Signal's protocol, we achieve the ability to securely distribute the decryption keys and necessary metadata to share members, enabling them to maintain secure access to the share state. This was an overview of how Debox implements data sharing. It might sound a bit convoluted, but most of this happens under the hood. The user is abstracted away from any complexity and merely needs to sync their files. So the final thing that we'll look at, fast and convenient data saving and retrieval. Users ultimately use cloud storage for saving data that exceeds their local storage capacity. And accommodating this functionality in Debox requires integrating with the IPFS Filecoin data persistence and retrieval ecosystem. The main ways for persisting data in the IPFS ecosystem are using an IPFS pinning service or some sort of equivalent, or Filecoin, with other projects such as Saturn and Titan that provide supporting retrieval functionality. Debox ultimately requires low-cost, decentralized, low-latency retrieval, mainly for relatively small amounts of data, megabyte, gigabyte, low terabyte range. So at this point, we have not yet been able to implement such retrieval using the current version of various IPFS ecosystem members. With IPFS pinning services, you're restricted with your reliance on a third-party service. With Filecoin, the saving and retrieval process is complex with high latency retrieval, even though we have seen much progress and are anticipating much needed improvements. And with something like Saturn, well, a CDN just isn't the best paradigm for private user data. So, in short, we do not have a solution for this at the moment. However, we are currently looking into things like IPC and FVM, other supporting platforms such as Spark and dStore that could potentially be instrumental in enabling us to implement this saving and retrieval functionality for the Debox network. So to sum up, Debox is on track with implementing native integration with the user's OS, offering easy data sharing, while we are actively working towards bringing data persistence and retrieval so that users would be able to store as much data as they need. For those that are interested to try out Debox, you can find us online, debox.network. Here's a QR code for the link. We just launched the website, so we're still in the middle of writing the documentation. But we do have a quick start using the Debox CLI interface. This is meant for users to get a feel for how Debox works. The CLI functionality will eventually be encapsulated in a much more friendly desktop application, as I mentioned. Nevertheless, it's there for you to check it out. Regarding our tentative roadmap, Q1 of next year, we will be releasing our first stable version, along with the core code base being open sourced on GitHub. In Q2, we are planning to release the full desktop version of the application. And by Q3, we plan to have a proof of concept for saving and retrieval. In Debox, we will be writing articles detailing our developments and posting them on our website and on Medium. You can also find us on X. So if you have any questions, please reach out to us. Otherwise, stay tuned for the latest news. Thank you.